In 1977, a radio telescope in Ohio picked up a signal so unusual that the astronomer monitoring the data circled it and wrote one word in the margin. Wow, that's literally what he wrote. The signal was so strong, so structured, so unlike anything that comes from natural sources, that a scientist at a major university used an exclamation of pure disbelief to describe it. The wow signal lasted 72 seconds. It has never been detected again. To this day, nobody knows what it was. And here's the thing. That's not even the strangest signal ever picked up from space. To understand why these signals are so unsettling, you need to understand what space normally sounds like. Space isn't silent. It produces radio waves constantly, from pulsars spinning hundreds of times per second, from gas clouds collapsing into stars, from the leftover radiation of the Big Bang still echoing across the universe. Scientists have cataloged most of it. They know what it looks like, what patterns it follows, what frequencies it prefers, which is exactly why certain signals stop them cold. Because some of what we've picked up doesn't follow any of those patterns. Some of it behaves in ways that have no accepted natural explanation. Some of it comes from directions in the sky, where there is, as far as we can tell, absolutely nothing. Fast radio bursts are the most baffling signals in modern astronomy. They last for milliseconds, literally a fraction of a second. But in that tiny window, they release more energy than the sun produces in 3 days. They come from billions of light years away. They arrive with no warning, and in most cases, are never heard from again. The first one was discovered in 2007, buried in old telescope data from 2001. Astronomer Duncan Lorimer found it while reviewing archival recordings and couldn't explain what he was looking at. It became known as the Lorimer burst. The scientific community was skeptical at first. A signal that powerful, that brief, that distant. It had to be instrument error. It had to be interference from something on Earth. It wasn't. More bursts were detected, then dozens, then hundreds. Telescopes around the world began finding them regularly once scientists knew what to look for. They were coming from all directions, all distances, completely at random. No pattern, no source, no explanation. Then in 2020, something changed. A fast radio burst was detected coming from inside our own galaxy, not billions of light years away, right here in the Milky Way. It was traced to a magnetar, a type of neutron star with an almost incomprehensibly powerful magnetic field. That seemed to solve it. Magnetars could produce fast radio bursts. Case closed. Except it wasn't. Because magnetars can't explain all of them. The energy levels are wrong for many bursts. The locations don't always match. And some bursts repeat, firing off again and again from the same point in the sky with a rhythm that nobody has been able to fully account for. One repeating source pulses every 16 days. Another appears to have a 157-day cycle. Why? Nobody knows. Then there's the signal that came from an entirely different direction, not from deep space, but from a nearby star. In 2015, a group of amateur astronomers noticed something strange about a star called KIC 8462852. It was dimming, not in the regular predictable way that happens when a planet passes in front of it. It was dimming irregularly, in bizarre patterns, sometimes losing up to 22% of its brightness at once. Nothing in normal stellar physics explained it. The internet named it Tabby's star after the astronomer who brought it to attention. And the theories that followed ranged from the mundane to the extraordinary. Dust clouds, cometary debris, a swarm of comets passing in unusual formation. And then there was the other theory, the one that made headlines around the world. What if it was a megastructure, a hypothetical alien construction so massive it was physically blocking the light from its own star, a structure built to harvest energy on a civilizational scale? Scientists were careful to say this was the least likely explanation. they were also careful not to completely rule it out. Years of observation later, the leading explanation is now circumstellar dust, material orbiting the star and blocking its light unevenly. Most researchers are satisfied with that, but the dimming events have continued, and they still haven't been fully explained to everyone's satisfaction. Tabby's star remains on the watch list. Back to the wow signal, because it deserves more than a passing mention. It was detected on August 15, 1977, by astronomer Jerry Ehman using the Big Ear radio telescope at Ohio State University. It arrived on a frequency of 1,420 megahertz, which is significant because that's the frequency of hydrogen, the most common element in the universe. Some scientists had theorized that any intelligent civilization trying to communicate across space would broadcast on that frequency, knowing others would be listening there. The signal matched almost perfectly what a transmission from deep space would look like if it were beamed from a single point and swept past Earth as the planet rotated. It was strong, it was structured, it was brief, and it came from the direction of the constellation Sagittarius, where there are no known stars or objects that could produce it naturally. Dozens of attempts have been made to find it again. Different telescopes, different frequencies, different times. Nothing. The sky in that direction is quiet. Whatever sent that signal, if anything sent it, has not repeated itself in nearly 50 years. There's one more mystery worth mentioning, and it might be the strangest of all. In 2019, astronomers detected a radio signal repeating with extraordinary precision every 16.35 days. Active for 4 days, silent for 12, then active again. Like clockwork. It was named FRB 180916. It came from a galaxy 500 million light years away. Natural objects can produce rhythmic signals. Pulsars do it. Binary star systems do it. But the 16-day cycle doesn't match any known natural mechanism cleanly. Some researchers think it could be the orbital period of two objects. A neutron star orbiting something else, with the signal only visible during certain parts of the orbit. That's a reasonable explanation. A working explanation, but not a confirmed one. Here's what all of these signals have in common. They are all real. They were all detected by multiple instruments and verified by serious scientists at serious institutions. None of them have been fully explained, and all of them sit in the same uncomfortable category. Things we know exist, things we can measure, and things we do not understand. Space is not a quiet place. It is constantly talking. We just haven't figured out what it's saying yet. If that thought keeps you up at night, good. Hit subscribe. There's a lot more to lose sleep over.